All right, final lesson of chapter 1, section 7. So taking you back to some good old geometry formulas. A lot of this has to do with sort of just rewriting formulas in different terms. So for example, if you look at the first one here, we have a right circular cylinder with a height of 8 inches. And so if we think of just think of your basic cylinder. I am not an artist, but you'll get the idea. So here's our cylinder. They're giving us a height of 8. And so they're talking about the volume of the cylinder. So I just threw this in as a reminder. So volume of a cylinder is pi r squared h. We were given the height, so that's why you're seeing the 8's already subbed in for the height. So it's just pi r squared 8. And so that's what it would be in terms of the radius. So when they say in terms of the radius or in terms of the diameter or circumference, that's what they're wanting to see within the formula. So this is just the basic formula for volume in terms of a radius. We're going to take that same setup though, and we're now going to convert it to being in terms of its diameter instead of its radius. So just think for a minute, how does the radius relate to a diameter, right? We know the radius is half a diameter. So we can sub out the r and put in d over 2 instead. So here's what it would look like now. And of course you can simplify that. So what they did was they took the 2 squared that's on bottom, so that's 4. That goes into 8 twice. So that's where you get the 2 from. And then you got the d squared right there. So once you simplify it, I mean, this is still the volume in terms of its diameter. This is just the simplified version of it. So it's good to simplify when you can. And then from here, one more time, they're now saying, so now take the volume in terms of its circumference. So think of your circumference formula, right? 2 pi r. We want to get r by itself so that we can sub it out from the original setup that you see right there. So if we divide over the 2 pi, it's going to look like this. So now instead of the radius, we can sub in c over 2 pi. And so this is the volume in terms of its circumference. If we clean that up, it would look something like this. So let's try one of these guys. And this is that point where you can stop or pause the video and try this on your own if you'd like. But we're looking at a right rectangular prism, has a height of 10. The base is a square. So let me see if I can draw that out real quick. Okay, so we have our right rectangular prism. The height is 10, so I'm seeing this as the bottom, the top, and so here's my height right here. And so this is my square base. And so my height is my 10. So for this, they're talking about the side lengths of the base. They want us to just use S to represent those. So, and it's a square, so it would be S by S for its dimensions. So the volume, really the same volume as the one we just did, but it's not going to be in terms of pi. So for this guy, it's just simply volume is the area of the base times the height. Or you could say length times width times height. You've probably heard that one before, I'm sure. So I'm going to say length, width, and height. The height we already know is 10. The length and the width are both S. So if we're going to do volume in terms of the sides of the base, so it's really going to be S times 10. And so if we do a little cleanup on that, just going to be 10s squared. So that would be our volume in terms of the S, which is the side length of the base. They're also wanting it in terms of the perimeter of the base. So of course the perimeter of the base would just be 4s. I want to get the s by itself, so I can sub it into this. So if I divide over the 4, then we're going to get p over 4 represents our side length. So we're going to sub that in for this guy. So volume is going to say 10 P over 4 squared. And then we can do a little cleanup on that. We know our 4 squared is going to be 16, so if we reduce our 10 over 16 to just 5 over 8, and maybe we would even write it this way. So there's our volume in terms of its perimeter of the base. So let me flip over. So we have our square with side x, that's these guys, is going to be cut out of each corner of this 8 by 15 piece of cardboard, so a rectangular piece of cardboard. And what they're basically, the idea is when we cut these out, we can then take those and fold them up to create the box, right? And so it won't have a lid on it. We're just going to fold up those 4 sides to create this box. So here's what that would look like for you. So this was our x by x square. And if we cut that out and fold up these sides, it would look like this. So keep that in mind. Where you see that x, right? If I fold this up as a side, that makes this the height of the box x, right? So that's that right there. So here's a couple things they're going to ask us to do with it. So as far as the volume as a function of x, so remember what we just talked about. We know our volume is length times width times height. Right? So there's our volume. So what is our length, width, and height? So we just discussed the height of x as we were looking at the other image. But what would we put in there for the length and the width? And you got to be careful on this one. So I'm putting in my height of x right there. So what would you put in for the length? We'll call this the length right here. Right? So the original was 15. But if I cut out an x here, and if I cut out another x here, all I get now is from here to there, right? So it was 15, but we just took away this x and this x. So now it's 15 minus 2x is my new length. The same thing is going to be true for our width. So 8 minus 2x. And so that's what we're subbing in into our volume formula. So it looks like this. So that would work. We could distribute here in order to clean things up a bit, but I don't know that you need to if it doesn't say to, or if it doesn't help you with another part of the problem. So for now I would leave it like this. What would the domain be? And remember, one way you can always look at domain is what numbers am I allowed to plug in for x, right? What can x be? Well, obviously it can't be 0 and it can't be negative, right? Because it represents the length of something in this diagram. So it's got to be greater than 0, but is there more to it than that? So, well, I'll hold off on that. Well, I'll write it this way for now. So let's just say x has to be greater than 0. So that's one thing that has to be true. What would it have to be less than? If you look at our smallest side up here, right? So if I'm going to cut out something here and here, right? Well, if this was like, look at it this way. If that was 4 and this was 4, would I have anything left? I mean, the total length is 8, right? And so if these are 4 or bigger, then this length would no longer exist, or this width would no longer exist. So whatever these x's are here and here, got to be less than 4, since I'm removing 2 of them, and I still need something left. So our x also has to be less than 4. All right, so greater than 0, less than 4. So we're just putting that in. We would probably write that this way. I'm going to say parenthesis, greater than 0, less than 4. So that's probably the best way to write our domain. All right, so find the value for x that produces the maximum volume. So this was going to become one of those super key calculus things that we're going to get into later when we do derivatives. When we discuss maximums and minimums, super strong link to our calculus stuff that we're going to get into. So for now, since we're not into the calculus portion yet, we're going to take advantage of our graphing calculator to help us find that answer instead, since we're not using calculus right now. So for that function, I'm just going to bring it down real quick. So we had 15 minus 2x. We had 8 minus 2x. And we had our height of x. So what we're going to do is throw that into our graphing calculator and take a look at that graph and use some technology here to find the height of it, or the maximum, we should say. And I'll show you where that domain really matters here in a second. Let me clear out those guys. So I'm going to type it in just the way I have it written on my page here. So just like this. So here's where the window matters. Our domain is only from 0 to 4, right? So when I find a maximum value, I have to find the maximum value within that domain of 0 to 4. So I'm actually going to go into my window right there, and I'm going to create a window of 0 to 4, and I'll just leave my scale as 1. I always leave my scale as 1. So what about the range though? So as far as from bottom to top, obviously it's not going to be negative, right? So I can put as my lowest point is 0. How do we know what the highest point is going to be? We really don't. So I had to toy with this until I could see all of the graph within my viewing screen from 0 to 4, right? And so if you put in, let's just say 10, or I'll just hit graph so you can see it. So if we only put in 10, well, here's from 0 to 4, and you can see where it started going up, and the peak is way up here, and then it came down right here, right? So my highest point is off my screen. So I would have to go back into my window and keep increasing my maximum, my Y maximum, until I get the whole graph on the screen. So I'll save you a little time here. Let's just go to 100 and hit graph. So now I can see the entire parabola on my screen. Definitely seeing the highest point within it. So we can use our max feature to calculate that value. So right here under calc, so I'm going to hit second and then calc, and we want the maximum. It's going to ask you those couple questions. So I have to make sure I am first to the left of my highest point and hit enter, and there's my left boundary. I have to be to the right of my maximum and hit enter, and there's my right boundary. So now when it says guess, I just hit enter one more time. It's going to tell me what the highest point is. So I want you to keep something in mind on this. Look at what the question asked for. It had said, what is the value for x that produces the max volume? They didn't ask for the max volume. So you have to be careful of what they are asking for, right? So this is the biggest x value that the x value I would use to find my maximum volume. If they said, what's your maximum volume? Well, there you go, right? So there's the maximum volume, because remember in this setup that we just graphed, right? Remember what the x's represent and the y represents your volume. So let me flip over. A little more fun with geometric shapes here. So this is one that just sort of came with a lot of sort of information here on the side, and so I wanted to just at least go through it with you. We don't have to work a separate one on our own. So here we go. We have essentially a parabola. What's being described here is they're using a satellite dish with a cardboard cylinder for protection. So here is the satellite, and this cylinder, which looks like a rectangle, it's because we're looking at it from the side. So this is actually a cylinder. Here's my version of it. I'll kind of be going back and forth. I drew this in, but so it's like if this is really circular, that line, but you're looking at it from the side, so it looks like a line. Same thing with this right here. This is really a circle, but we're looking at it directly from the side, so it's like it looks like a line to us. So they're describing this cylinder that they are going to place into this satellite dish so that it is flush with the top of the dish, but they're using it as like a protection for the dish. So that's kind of what's going on here. So they said that the parabola is 16 inches in diameter, so you can see my drawing on that, and 4 inches deep. So from here to here would be 4 inches. One thing we're going to have to figure out is what is this gap, because we need to know how tall to make this cylinder, right? That's essentially what they're going to be asking here. So how tall is that cylinder to fit in the middle of the dish? So I drew this picture because I felt like their description was a little unclear. So it took me a minute to kind of figure out how to draw even what they were describing. But what they did with this to be able to use like a formula or an equation for it was they said, well, let's take this parabola and fit it into a coordinate grid, right? And so that's what you're seeing right here. So they made the vertex at 0, 0, right? So this, think of this as 0, 0. So that right there. And then obviously because of the diameter, they went 8 to the right and 8 to the left to get a total of 16. And because it's 4 units high, that's why they're making the y coordinates both 4, right? And so they're fitting this into our coordinate plane. What we can do with that then is, because it's a parabola, we can just use the model of the formula for a parabola, which is y equals something x squared. We get the very simple version of a parabola because our vertex is at 0, 0, right? So that's obviously why we would want to put it in the center. So if our vertex is 0, 0, then it's just y equals, they have it as kx squared. I think I would have said ax squared, but either way, this k represents our vertical shrink that we got going on here. So we have to figure out what that shrink is, because obviously this is not the typical parent function of a parabola, right? It's like it's been flattened. Okay, so we had to figure out what that k value is. So we're just picking either point on the graph, right? This one or this one, and they're going to plug in the 8 for x and the 4 for y so that it looks like this. And then if you solve for k, we figure out that it's 1/16. So here's our model, right? So we can now see it as y equals 1/16 x squared. All right, so we now have our model that we need to work with, and now we got to do a little thinking here as to how to come up with the information that they were asking for. So remember, what they were asking for was this height right here. Okay, so something they told us in the given information is that the diameter of the cylinder is 8. So from here to here was 8, and I labeled that on my first diagram. So in terms of the coordinate plane that they had up above, remember this was at 0, 0. And so if this is 8 units long, that means it would be 4 to the right and 4 to the left from there. So that's why I know these coordinates have an x coordinate of 4 and an x coordinate of -4. So we're going to come up with this point right here. Knowing that our x coordinate would be 4, we can sub that in. And that tells us that the y coordinate at that point is 1. So that created a point right here for us of 4, 1. So if you kind of think in terms of from here to here, we saw way back at the very beginning, they told us that from bottom to top was 4, right? And so we just figured out that this point right here is 1 unit high. So if that's 1, what does that leave you with for the height of your cylinder, right? And so that leaves us with that height of 3, and that was what they were looking for. So that was a tricky one. So I wanted you guys to see kind of how you could take advantage of sort of your basic knowledge of a parabola or quadratic, as well as fitting something into a coordinate plane in order to sort of work with the numbers that they're giving us. So let me flip over to our very last page. Alrighty, last one here. So one of the keys on these guys is just reading very, very carefully. So what they're talking about is this cone here represents a pile of grain that's been pouring out of a storage bin. So that is a pile of grain right there. It's been pouring out at a rate of 5 cubic inches per minute. So a couple keys right here. What does cubic tell you? So we know cubic is volume. So that's why we're going to be using a volume formula. It's also inches per minute. And down here, it's going to ask like how tall is it going to be in 2 hours, right? So we're going to do things in terms of inches. So couple keys within this. We also know that the height right here, the height of the cone always remains equal to the radius. So that's super important because we can put these guys into common terms since they're always going to be equal to each other. And if it is 12 inches tall right now, right, because we're going to do things in terms of inches because the rate they gave us. So if it's 12 inches tall right now, how tall is it going to be 120 minutes from now, right? And again, because they're using per minute, I want to work in minutes as well. So we're going to think 120 minutes. Okay, so let's get on with this. So first things first, what is the formula for volume of a cone? Almost the same thing as volume of a cylinder, but you got the 1/3 in there as well. So 1/3 times the area of the base times the height. So what can we do with this formula since our radius and our height are always equal? Down here they say they want us to write the volume as a function of height. In other words, we want h in there and not r. Right? Well, since these are all the same, since these are equal, you could think of this as h squared times h, right? Or if we simplify that, we can just say pi h cubed, right? And so now it's in terms of height. So when the height is 12, and remember that was because they said if it is 1 foot tall now, so if it's 12 inches now, what would the volume currently be? Because we need to compare what it is now to what it is 2 hours from now. So we need to first know what we're dealing with here. So if our height is 12, so if you did 12 to the third times pi divided by 3, that will give us our current volume. So we got right here, I did 12 to the third divided by 3. I'm going to leave pi in there for now so that I don't get an irrational number. So we're going to say 576 pi is our current volume. Might just be easier to work with since we're not done with the problem yet. The fun never ends. So here we go. This is what we started with for the volume. What will it be 2 hours later? This is the rate that they gave us, 5 cubic inches per minute. And this is going for 120 minutes or 2 hours. So here's our little conversion. So we're using our rate for 120 minutes. What would that come out to be? Or in other words, what is 5 times 120? So 600 would be our So this is how much it will have grown by. So this is how much is being added on to this over the next 2 hours, right? So what would the total volume be if I just add those two things together? So we could go decimals at this point. I'm just going to say, actually I'll do this. So I got my 576, there we go, times pi. So that was what we started with. We're just now adding on 600 more. And so 24, let's call it 2410. I'm just going to round it. So we're going to call it 2410 cubic inches total 2 hours later. And ultimately they had asked us for the height of it. So they said, how tall will it be in 2 hours? So we are solving for h. We are solving for height. So before I start plugging in numbers here, let's just clean up our formula or rewrite it. So we're putting it in terms of height right here. So that equals our, so this was our volume, right? So if I wanted to get h by itself, right, we already know the volume is going to be this. So we're going to plug that in, but so we're just solving for h at this point, which means I would need to multiply by 3 and divide by pi in order to get this next step. So it's my volume times 3, and all of that is over pi. And then last, of course, to get h by itself, we would cube root both sides. So we're going to say our height is simply the cube root of 3v over pi. So it's looking something like this. So now, knowing what our volume is, right, if we put this guy in for v and throw that into the calculator, we have our height. So that's it for this. As I put down here at the bottom, just as a little bit of a side note warning, you know, when it comes to doing word problems like this, there are so many types of problems they can give you. So my goal was to take some of the more common ones and some different ones, so that hopefully you could just use those as a base to tackle the homework problems that you're going to run into. I do have the worked out solutions posted for you just in case you are stuck on those, but you know, feel free to come to me with questions at any point, and make sure we get it all figured out. So that is the end of chapter 1.